Hello again, dear grade 11 students. Let's continue more training exercises using quadratic equations. Here we go with training exercise 3. As you see, we have a scalene triangle ABC. We have the height represented by x prime and BC represented by x double prime. Of course, x prime and x double prime are going to be the roots of a certain quadratic equation. Okay? And of course they are positive values because they are measurements. We have given that x prime plus x double prime is 10, and of course whenever we see a height and a base we have to think of the area. So we have to find x prime and x double prime, knowing that the area of that triangle is 10.5, and we have this given that x prime plus x double prime is 10. So let's think a little bit. Why do we have this, and why do we have to talk about the area, or where should we use the area? According to this, x prime plus x double prime reminds us of the sum. Whenever we see x prime plus x double prime, which is the sum of the two distinct roots, then we have to remember as the sum. Okay? And according to the area, let's see later what we should do. But before, let me review something, that if I have the sum and the product of the roots, and I will have this later, then I can form this quadratic equation of the form x squared minus sx plus p equals to 0, and after that I can solve it and find x prime and x double prime. So that's our plan. We have to use S and P to form this equation, so we have to pay attention whenever we're given x prime plus x double prime and something related to x prime dot x double prime, which is the product. We can use the sum and the product to form a quadratic equation, and then by solving that quadratic equation we will get x prime and x double prime. So let's continue how to benefit from that given. The area of a triangle is definitely the height times the base over 2. So x prime times x double prime over 2 is the second given, that's equal to 10.5. So the first given is that x prime plus x double prime is 10. That means that s, the sum of the roots, is 10. And x prime dot x double prime over 2 is 10.5. That's the area, height times base over 2. Then definitely x prime dot x double prime is 21, which is the product. Now I have the sum, I have the product. I apply the rule that says x squared minus sx plus p equals to 0. I just apply that rule to form the quadratic equation you see here. X squared minus 10x plus p, which is plus 21, equals to 0. Now I simply use the calculator to find the roots. I have to press mod 5 3. Now the number multiplied by x squared is a, it's 1 here, equal b is minus 10, and equal again c is 21. And finally I'm going to get the roots. One of them is 7 and the other is 3. So I named the smaller one x prime because according to the figure the smaller one is x prime, which is a 3, and the larger one, which is BC, which is x double prime, is 7 according to my figure. So that's according to that exercise. All what I have to do is to benefit from S and P, the sum and the product, to form a quadratic equation using the rule of x squared minus sx plus p is 0, and then to solve it using the calculator. Now let's see what we have in this training exercise number 4. So as you see, we have like a system. We have to solve that system. To solve that system means to find x prime and x double prime, which are the real variables in that system. So x prime plus x double prime plus 2x prime x double prime is 9. 2 into x prime plus x double prime minus 5x prime x double prime is 9. So let's remember, whenever I see x prime plus x double prime, that's s. Whenever I see x prime dot x double prime, that's p. So here also is p, and here is s. And now we transform the equation, the system, as follows. It is s plus 2p is 9 and 2s minus 5p is 9. Now again, let's use the calculator to solve this equation. Here we are going to use mode. Again, equation is 5, so 5. Now we are going to use the equation of two unknowns, two equations and two unknowns, so I have to choose one. So 1. Now a is the number multiplied by the first variable, so 1 equals, then 2 equals 9. Now I move to the second equation. 2 equals the number multiplied by the second variable is minus 5. I take it with its sign, equals 9. And thus one of the roots is 7, which is s, the first one. X means the first variable. I have to arrange them. S over S, P over P, equal over equal, and the number over the number. So the first variable according to that calculator here is S, and the second variable is P. So the first variable is 7 and another equal. The second variable is Y, which is P here. It is 1. So by this, we reviewed how to solve a system of two equations and two unknowns using the calculator. Now, after getting S and P, let's remember the general form: S squared, X squared, minus SX plus P equals to 0. So all what I have to do is to form a quadratic equation, which is x squared minus 7x using this sum. It is 7, so minus sx means minus 7x plus 1 equals to 0. So every time I'm benefiting from the sum and the product to form a quadratic equation, and every time I form a quadratic equation, I can find the roots. Now again, I will use the calculator to find the roots. Now I will delete this. Now using the calculator here, I'll press mode 5, 3. So when I have to use the system of two equations, two unknowns, to solve it, I use 1. When I have to solve a quadratic equation, I use 3. Now a is the coefficient of x squared, which is 1. B is that of x, which is minus 7. And c is the constant. And finally, as you see here, the first root is 7 plus 3 radical 5 over 2. The second root is 7 minus 3 radical 5 over 2. And by this, I solved the system and I found x prime and x double prime.